Step into the wood shop and witness raw timber transformed into craftsmanship. Hear the roar of saws, feel the rush of fresh cut wood, and watch artisans bring each piece to life. Hit play, like and subscribe, and drop your thoughts in the comments. Have you ever wondered what happens behind the scenes of the wood industry, how raw timber is turned into smooth panels, powerful fuel, or high-grade furniture components? Welcome to this deep dive into the world of wood crushers and wood processing machines, where steel meets timber and innovation fuels productivity. In the next 20 minutes, we're going to explore the different types of wood crushers, how they work, their applications, and what makes each machine unique. But before we jump in, tell me, do you like this kind of intro? Do you want more content like this, explained with clarity, energy, and real-world relevance? Drop your thoughts in the comments or hit that like button. Your feedback fuels this content, and just like diesel fuels a drum chipper. Now, let's get to the heart of wood processing. On a crisp morning at the log yard, large tree trunks lie in rows waiting to be processed. In the middle of this scene stands a distinctive blue machine, an industrial wood grinder designed to turn raw timber into fine sawdust for multiple industries. This drum-type wood grinder consists of a sturdy engine base, a knife drum fitted with sharp serrated blades, an in-feed system with upper and lower conveyors to push wood into the machine, a discharge conveyor to carry sawdust out, hydraulic buffers to reduce vibration, and an electrical control system to monitor operating parameters. Such a structure allows it to handle not only logs but also branches, wood waste, and even some non-wood materials. Before starting, the operator, fully equipped with protective gear, checks the blades, the tension of the conveyor, and ensures there are no foreign objects in the infeed chamber. Safety sensors and emergency stop buttons are verified to guarantee maximum security. Once the machine runs, a crane places logs onto the feed part. The wood is pulled into the drum, where high-speed blades slice it into chips and then grind those chips into sawdust. The process is continuous. Wood goes in at one end, sawdust comes out on a conveyor at the other. Each hour, the machine can grind dozens of cubic meters of wood, producing large quantities of sawdust for making particle board, fuel pellets, or organic fertilizer. Collected sawdust is loaded onto trucks and transported to factories. From these tiny particles, people produce biofuel pellets, composite boards, or use it as a substrate for mushroom cultivation. Thus, timber is utilized to the fullest, reducing waste. After a shift, the machine is shut down for maintenance. Mechanics remove the cover, sharpen the blades, lubricate components, and clean out any remaining sawdust. Regular maintenance keeps the grinder running smoothly and prolongs its service life. As the sun sets, the grinding plant falls silent. The smell of wood and sawdust lingers in the air, signaling a productive day has come to an end. The wood grinder is not only a symbol of mechanical power, but also evidence of ingenuity in maximizing forest resources. This technology plays an important role in the sustainable and efficient production chain of the forestry and wood processing industry. A log is placed on the loading table and the conveyor starts pulling it toward a fixed chainsaw. The saw drops and cuts the log into shorter lengths in an instant. As soon as the cut is complete, the conveyor pushes the section into the splitting chamber. A powerful hydraulic piston forces the wood through a cross-shaped wedge, cleaving it into equal pieces. The split pieces fall onto a second conveyor and are carried to a collection area. Throughout the process, the operator stands at the control panel monitoring the feed speed and hydraulic pressure, ready to make adjustments if needed. An automatic lubrication system sprays oil onto the chainsaw and splitting blades to keep the machine running smoothly. When the batch of firewood is finished, the machine is stopped for inspection and cleaning before the next run. In a modern wood processing facility, long tree trunks are stacked neatly beside a set of interconnected machines forming a single production line. At the heart of the system is the wood grinder, but its effectiveness depends on the surrounding automation. Together, these components transform raw timber into fine sawdust quickly, continuously, and safely. Logs are placed onto the in-feed conveyor, where rubber and steel rollers grip them and carry them toward the machine's mouth. Upper and lower feed mechanisms hold the logs steady to prevent them from bouncing or slipping. As they reach the drum-type grinder, the knives on the rotating drum go to work, spinning at high speed and slicing the wood into small chips. These chips continue to be pulverized as they collide with the drum housing and secondary blades, turning into fine sawdust. A discharge conveyor at the end of the grinder moves the sawdust onward, preventing clogs. The sawdust then passes through a screening system that removes any oversized pieces. Chunks that are too large are returned to the grinder for another pass, while sawdust that meets the specification travels through an enclosed conveyor to a collection area. There, a dust extraction system separates the sawdust from the airflow, minimizing airborne dust and keeping the workshop clean. An operator monitors the entire line from a central control panel, watching belt speeds, grinding power, and engine temperature. Sensors issue warnings if the machine is overloaded or if a foreign object becomes trapped, allowing the line to stop instantly for troubleshooting. The whole process, from feeding logs to collecting sawdust, is nearly closed loop and requires only a few staff members to supervise. Sawdust has many uses. It is feedstock for particle board, MDF, and OSB. It can be pressed into clean fuel pellets, or it serves as a substrate for mushroom cultivation. Producing sawdust on a conveyor line helps maximize the use of timber and waste material, reducing labor costs and processing time compared with manual methods. At the end of a shift, the line is shut down for maintenance. Workers clean the conveyors, inspect and sharpen the knives, lubricate bearings, and replace dust filters. With regular maintenance, the system is always ready for steady operation in the next production run. The conveyor-based wood grinding line not only boosts manufacturing efficiency, but also contributes to a sustainable value chain in the wood processing industry. large woodyard, a worker prepares to operate the wood grinder. Cut logs lie ready beside the in-feed conveyor. After safety checks, tension of the belts, condition of the knives and control systems, he starts the machine and the conveyor begins to move. The first log is placed on the belt. Feed rollers grip it tightly and draw it into the drum. Inside, a drum fitted with dozens of serrated blades spins at high speed. When the wood makes contact, the knives shave it into small chips. These chips are further crushed as they strike the housing and secondary blades, quickly becoming fine sawdust. The particles are carried on an air stream and drop onto the discharge conveyor. Throughout the process, the operator watches parameters on the control panel. Rotation speed, engine temperature and power consumption. If a log is too hard or too large, an overload sensor triggers and the conveyor stops to prevent damage to the knives. As the sawdust is discharged, a dust extraction system collects fine particles into filter bags, keeping the surrounding air clean. Finished sawdust is gathered into bins. It will be used as feedstock for particle board, biofuel pellets, or as mulch in agriculture. Converting waste wood into high-value products is the main goal of this line. At the end of the shift, the worker shuts down the machine, allows it to cool, then performs maintenance, removing and cleaning the knives, inspecting the conveyor, lubricating bearings, and cleaning the dust filters. He assesses the amount of sawdust produced and plans the next day's feedstock. Even though the wood grinder is not massive, the efficiency it provides is significant, saving time and labor while turning otherwise discarded wood into useful sawdust. The workday begins with the roar of machinery in the sawmill. A technician powers up the systems, checks the cooling circuit and fills the lubrication reservoir. A massive circular steel saw blade spins up to speed, glinting under the lights. Feed conveyors stand ready to push long logs toward the cutting table. The first log is fed in. Two clamps hold it firmly as the blade contacts and cross-cuts the trunk into billets of predetermined length. Sawdust flies, but the dust extraction system immediately captures it, keeping the cutting area clean. The technician watches the control panel, adjusting cutting speed to suit the diameter and species of wood, while controlling the water spray that cools the blade to prevent overheating. Next comes the ripping stage. The freshly cut billets are moved to a ripping saw to be split into planks of varying thicknesses. The operator adjusts the fence on the saw table to set the board width. The blade height and angle are calibrated precisely. As the machine runs, the log advances slowly past the blade with a steady whir. Each board emerging from the saw is sorted into categories: main boards, secondary boards, or beams. Boards with defects such as knots or cracks are marked for separate processing. After ripping, the boards are sent to the planer to flatten and achieve uniform thickness. The technician sets the cutter head depth and feeds boards through the rollers. The surfaces come out smooth, ready for sanding. A worker uses a large belt sander to process long boards, while smaller or intricately patterned boards are smoothed with handheld orbital sanders. The sanding machines whine as layers of wood fiber are polished away and the surfaces become bright and clean. Safety is paramount throughout the operation. Every worker wears protective glasses, masks, and hearing protection. Emergency stop buttons are placed in multiple locations to shut down machines immediately if something goes wrong. Sensors monitor vibration and detect blade misalignment. When an alarm sounds, the saw automatically slows and stops for inspection. As the shift draws to an end, the saw is shut down for maintenance. The technician removes the blade from the arbor, checks its wear, and sharpens it with a specialized grinder. The shaft and bearings are cleaned and lubricated. Conveyors and rollers are brushed free of sawdust and sprayed with anti-corrosion oil. At the same time, the operation log records the volume of wood sawn, species, board thicknesses, and operating time. Finally, the sawmill falls quiet again. Straight, smooth boards are stacked neatly, ready for transport. The saw has done its job, transforming rough logs into high-value semi-finished products that await the next stages of processing. As winter approaches at a small rural woodshop, a worker gets ready to operate a hydraulic wood splitter. Unlike chainsaws or rotary blades, this machine uses the raw force of a hydraulic piston to push logs through a splitting wedge. The machine is mounted on a sturdy steel frame. On one end, there's a flat backstop where the log is placed upright. In the middle sits a sharp wedge in a V or cross shape. And on the other end is a hydraulic piston powered by a pump and cylinder. When the switch is turned on, the engine activates the hydraulic system, building pressure and preparing the piston to move. The operator lifts a log and places it against the wedge. With a pull of the control lever, the piston slowly pushes the log forward. As it meets the wedge, the wood begins to split along its grain. A sharp, cracking sound echoes as the log is cleanly divided into 2, 4, or even 6 pieces, depending on the wedge shape. The split firewood falls to the sides or onto a conveyor for collection. The process is repeated quickly. The piston retracts, a new log is loaded, and the cycle continues. Thanks to the machine's strong force and smooth motion, each log takes just a few seconds to split. It can handle even the toughest hardwood without effort from the user. Built-in safety valves release excess pressure if an obstruction is encountered, preventing damage to the piston or blade. While operating, the worker wears gloves and safety boots, keeping hands away from the cutting zone. The machine is equipped with a protective shield to prevent flying debris, and emergency stop buttons are located near the controls in case of trouble. At the end of the shift, the machine is powered down and cleaned. The operator brushes away wood chips, inspects the wedge, cylinder, and hoses for wear or leaks, and refills the hydraulic oil if needed. All bolts are rechecked for tightness. With regular maintenance, the piston wood splitter runs smoothly throughout the cold season, ensuring a steady supply of firewood for heating and cooking in nearby homes. At a logging site, a worker grips his chainsaw firmly and checks the chain tension, fuel level, and starter cord. With a few pulls, the engine roars to life, its powerful hum echoing through the trees. He lowers the saw, and the chain spins rapidly, producing a sharp mechanical whine. The bar meets the thick tree trunk, slicing cleanly through the bark and deep into the grain. Sawdust sprays in all directions as the sharp chain chews through the wood. The worker follows a precise cutting line, shifting his stance slightly to maintain balance and steady pressure. Within seconds, a large section of the trunk is severed. He turns off the engine and places the saw down, inspecting the cut. Straight, smooth, and efficient. That's the power of a chainsaw. Compact, agile, and incredibly effective in the hands of a skilled operator. Across a field overgrown with tall grass and dense brush, a wheel loader rumbles forward. Mounted on the front is a fast-spinning rotary or drum-type clearing head, its blades sharp and relentless. As it moves, thick vegetation is shredded instantly, leaving a clean path behind. Dust clouds rise, but the operator stays protected inside the sealed cab. In just a few seconds, a large patch of land is cleared with precision. Powerful, efficient, and built for tough jobs, that's the force of this all-terrain clearing machine. At a busy quarry site, the thunderous sound of metal on stone fills the air. A massive rock crusher is in full operation. Large boulders are loaded into the hopper, slide down the vibrating feeder, and enter the crushing chamber. Inside, powerful jaws or rotating hammers apply intense pressure. As the stones are gripped, they crack, collide, and grind against one another. With every rotation, the rocks are broken down into smaller fragments, gradually reduced to sharp-edged gravel. The entire process is closely monitored through a control panel. Crushing speed, vibration, motor temperature, and power levels are all tracked in real time. A conveyor belt carries the crushed material out of the machine. There, a vibrating screen sorts the gravel by size. Coarse gravel for road foundations, medium-sized aggregate for concrete, and fine material for filling or landscaping. Each grade serves a specific purpose in construction. To ensure safety, the machine is surrounded by heavy-duty guards and equipped with emergency stop sensors. The operator, wearing goggles, a hard hat, and noise-cancelling headphones, keeps a safe distance at all times. At the end of the day, the crusher is shut down for inspection, jaws are checked for wear, shafts are lubricated, and the entire area is cleaned and secured.
Cái này có khả năng chạy nhanh hơn đấy. ไม่หมุนละไม่หมุนละ Vừa tầm đó luôn. Mà trong cái tăng tăng có nọ đấy. Tăng cái nhanh.